Welcome to the debate. So today, we're diving into the core tension in modern AI governance, and we're drawing this directly from Erickson Katz's phenomenal article, Airplanes Don't Flap.
Which is, it's a foundational piece for anyone building in this space.
Absolutely foundational. And the central question we are exploring today is this. When we govern AI, should we be focusing on the structural limitations of the models themselves, like obsessing over whether they possess any genuine biological understanding? Or should we focus entirely on the operational task envelopes and the socio-technical systems we build around them?
Right, the system versus the engine.
Exactly. Now, I'm approaching this today from the perspective of a skeptical executive.
Well, I come at it from a different way.
Governance really shouldn't obsess over whether an AI understands because, frankly, that is a metaphysical distraction. We need to prioritize the deployed system architecture. We have to treat AI as a composite tool.
When you strip away the marketing hype, what are we actually dealing with under the hood? At the level of the core model architecture, transformers are fundamentally stateless between sessions.
Right, they don't have persistent memory of who they are from one prompt to the next.
Exactly. The decoding process is purely probabilistic. There is no resident I in the weights. There's no agency, no self-coherence, and, importantly, no grounded understanding of the physical world.
Just next token prediction.
Right.
Well,
Think about the sheer amount of human validation. It all points to a singular truth, which is that we are paying for scaffolding to contain a statistical process that fundamentally does not know what it is doing. Governance has to start by granting this reality.
I hear you, but the reality you are describing is solely the reality of the core model. It's the reality of the engine. But nobody flies an engine, right? They fly an airplane. And as Katz's title reminds us, airplanes don't flap. The persistent error in this entire discourse is the assumption that there is only one architecture under discussion.
There are two entirely different things happening here. There's the core model architecture, and then there's the deployed system architecture. Critics constantly attack the core layer, the statelessness, the probability, the lack of an inner eye, while completely ignoring the controls that exist outside of it.
But the core layer is what generates the text.
Sure, but when we deploy AI in a production environment, we do not just unleash a raw transformer onto the internet. We wrap it in retrieval systems like RAG, we add memory layers, policy filters, tool integrations, and, human review gates. As the NIST AI Risk Management Framework outlines, we are governing a socio-technical system.
Okay, but
So if you ask, does this system really think? You are asking a philosophical question that honestly forecloses productive governance. The real question we should be asking is, what exactly are we asking this system to do, under what conditions, and with what verification?
you mentioned RAG, retrieval augmented generation, and policy filters. From an executive view, those are just fragile layers of scaffolding trying to contain an uncontrollable statistical process.
They aren't fragile if engineered correctly.
How can you govern a system where the core generator of language has absolutely no commitment to the truth of what it is saying?
Because in a deployed architecture, the model isn't the thing making the commitment to truth. The composite system is. You are looking for an internal locus of control, like you want a tiny accountable soul inside the machine. But what deployed systems possess is an externalized center.
An externalized center. Wait, explain how that actually works in practice.
Right, so the center of decision-making does not reside inside the learned weights of the transformer. It resides in the architecture surrounding them. It is composed of the business priorities that optimize the system, the retrieval pipelines that strictly privilege authoritative knowledge over parametric guessing.
Over the model's own memory.
Exactly. And the policy filters that shape what can be output, and the governance rules that determine escalation. The center of the system is not consciousness, it is control. What steers the outcomes is not what speaks. The model generates possibilities, but the externalized center selects, filters, and bounds them.
We govern institutions this way all the time, right? A massive corporation doesn't have a single biological brain, yet we govern its outputs through incentives, policies, and rigid structures. The lack of an inner eye isn't a failure of the AI system, it's just a characteristic of the component we use for generation.
Executives hate variance. We want the same input to produce the exact same output. We want a reliable machine. So what do engineers do when executives demand reliability? They adjust the decoding constraints.
Right, you drop the temperature.
Exactly. They turn the temperature down to 0. Mechanically, they force the model to use what's called argmax selection. Instead of rolling the dice among a few likely words, the system just looks at the probability distribution of the next possible word and picks the absolute highest percentage every single time.
Which makes it deterministic.
If the model's highest probability token is factually incorrect, the system simply produces the exact same wrong answer every single time. It creates what we call fossilized error.
Yeah, it confidently repeats the hallucination.
Yes, repeatability masquerades as competence. And as a governance problem, this is actually more dangerous than randomness. When an engine is randomly wrong, a human operator auditing the system can spot the variance. They see the model shifting its answers and they recognize the uncertainty.
Because the output flickers.
Exactly. But when it is confidently and repeatedly wrong because we forced it into determinism, it slips right past human review. By trying to put a rigid steering wheel on a statistical process, you haven't made it safer, you've just made its failures harder to detect. You fossilize the error.
That's a compelling argument. But have you considered that determinism does not dissolve the problem, and Ketz specifically addresses this paradox? The disappearance of randomness just changes the governance regime rather than proving governance is impossible. You are absolutely right that if you move to a deterministic regime, you cannot use the same instrumentation you used for a sampling-based system.
Because the signals of failure are totally different.
Precisely. In a sampling-based system, with the temperature turned up, you manage risk through variance checks. You might run the same prompt 5 times and use intermodal disagreement diagnostics, basically treating the divergence as a signal that the model doesn't actually know the answer.
Right.
But when you move to determinism and risk fossilizing error, the governance response has to adapt mechanically. Deterministic systems require hard-coded abstention criteria.
Meaning the system is programmed to say, I don't know?
Yes, they require formal verification where it's tractable, and most importantly, trusted source grounding. The system is programmed to explicitly refuse to answer when the retrieval fails, rather than falling back to guessing based on its parametric memory.
Okay, but
The problem isn't that the engine is inherently unmanageable. The problem is when governance controls are mismatched to the operating regime. If you apply sampling-based oversight to a deterministic system, yes, it will fail silently. But a mature governance framework anticipates this. We define the task boundaries, and we instrument the vehicle accordingly.
I'm not convinced by that line of reasoning. The sheer cost of governance is a direct indictment of the technology's foundational architecture.
I'm sorry, but I just don't buy that. Let me tell you why. You're equating the cost of validation with a broken tool, which just isn't fair. It is a fundamental misreading of how powerful systems scale in the real world. Let's look at aviation again, or finance, or medicine.
Okay.
The aviation industry spends billions of dollars on checklists, maintenance schedules, air traffic control, and highly redundant safety systems. Do we look at the FAA and say, wow, the high cost of validation proves that jet engines are a hollow illusion?
No, because jet engines obey the laws of thermodynamics.
But the point is about leverage. We recognize that powerful systems operating at scale, with high stakes, naturally create new layers of supervision precisely because their leverage is so real. The presence of governance cost does not prove uselessness, it proves consequence. The human validation energy isn't rent on scaffolding. It is the expected expense of operating a probabilistic system in a high-stakes corporate environment. And this is exactly where enterprise semantic integrity, or ESI, becomes incredibly operational. Because the real risk we are governing isn't just a model hallucinating a wrong token. The real risk is semantic drift.
For the listeners, semantic drift, as Katz defines it, is the unmanaged semantic pragmatic collapse across organizational systems, which is, really just a fancy way of saying there is a massive gap between a company's declared policy language and the model's actual operational execution. You cannot outsource decision-making to a system that doesn't understand what a decision is.
But we aren't outsourcing institutional accountability to the model. That is the core misunderstanding of the engineering approach. Accountability always resides in the socio-technical system, in the human in the loop, in that externalized center we talked about.
So how does EOSI actually prevent the drift mechanically? Because words are just words.
You specify, domain by domain, what the system must reliably preserve to be trustworthy. Let's use a concrete example. Imagine a bank using AI to assist in financial planning. The ESI framework defines exactly what semantic constraints the retrieval and generation pipelines must adhere to.
Okay.
The CSID might dictate that the concept of guaranteed return is semantically restricted, so the model is mechanically blocked from associating that phrase with volatile assets. The system uses secondary models and deterministic filters to actively monitor the output against that specific dictionary definition. If those constraints are violated, the system doesn't just guess, it defaults to refusal or escalates to a human advisor.
So the system is constantly double-checking the model's math against a hard-coded dictionary of corporate meaning.
Yes, exactly. We transition from metaphysical questions like, does the model really know what financial risk is, to practical engineering governance. What are the measurable semantic constraints placed on this operational envelope? We manage semantic drift the exact same way we manage drift in human bureaucracies, through clear policy, continuous auditing, and structural alignment. We are paying for a powerful but narrow set of capabilities.
I see.
The tool is not the problem. The expectation that the tool should act as an autonomous general intelligence is the problem. Expectation is something leadership can specify, measure, govern, and correct.
But even if we accept that leadership can specify these expectations, we have to acknowledge the fragility of this paradigm.
How is it fragile?
You say accountability resides in the socio-technical system, but in practice, the sheer volume and velocity of the outputs generated by these models completely overwhelm the human operators tasked with reviewing them. This is the danger of the externalized center. It assumes that the control mechanisms are robust enough to catch the failures of the core engine at scale.
Which is why we automate the constraints.
But as Katz points out, failures often arise because controls are mismatched to the regime. Governance rooted in deep skepticism of the engine is not a philosophical luxury, it is an operational imperative. We must govern these systems with the constant awareness that at any moment, the mirror could shatter, revealing the empty space behind it.
Skepticism is incredibly healthy, but paralysis is not. I return to the airplane.
The airplane that doesn't flap.
Exactly. A bird has intrinsic biological constraints. It understands wind, fatigue, and the need to survive. A Boeing 777 has none of those things. It is a dead machine. Yet, through rigorous systems engineering, redundant controls, and strict task envelopes, it transports millions of people safely every single day. We achieved flight not by building a better bird, but by mastering lift, thrust, drag, and weight. AI governance must follow the exact same path.
By mastering the boundaries of the envelope.
Yes, we need to stop waiting for the model to develop an inner eye and start doing the hard, tractable work of specifying the cognitive envelope. We must ask the engineering questions. Where can this system fail silently? Which decisions require mandatory human review? What sources are being retrieved? How is drift detected against our CSID?
Well, it seems we have found some significant points of convergence today. We both absolutely agree that deployed AI requires extensive, costly oversight, and that raw, unconstrained foundational models are wildly insufficient for enterprise use.
Without a doubt.
And the validation costs are very real, whether you view them as a symptom of a hollow core, as I do, or the natural price of operating powerful systems at scale as you do.
And we also agree that different operational regimes, like deterministic versus probabilistic decoding, require entirely different governance instrumentation. You can't just apply one set of rules to every type of model behavior.
Exactly. Where we remain in thoughtful disagreement is whether the foundational model's lack of true understanding is a persistent underlying liability that inevitably undermines the whole system, or simply an irrelevant metaphysical detail bypassed by sound engineering.
It's a debate that's going to define the next decade of software.
It really is. The source material by Erickson Katz offers profound depth on how institutions can begin to map these exact controls and navigate this tension. Are we painstakingly building an elaborate structure of scaffolding just to hold up a giant empty mirror?
Or are we learning how to carefully aim a powerful new lens?
That is the governance challenge of our time.